compatible with the JSON.parse that we have for parsing the any JSON objects. So whenever possible, we can avoid using eval function and rather opt for JSON.parse. Then we have the process of debouncing. So whenever there is a situation where we have some events generated, let's take an example of um, the searching that we have, the automatic searching that we have when we type in something in the text field for the search input. So that there we need to call a function or the API to fetch uh, needed request, the needed result for the keyword that is entered. So in that scenarios, what will happen if we try to call that function again and again on every key that is typed? So that will result into multiple unnecessary API calls. So that kind of scenarios could be avoided using the debouncing approach, where if certain action or event occurs within, let's say, a time frame, let's say here I have taken example of 300 millisecond, then if that event occurs within that, I mean the consecutive events occur in that within that time frame, then that call or the action that is to be performed will not go through. Rather, the next event that is out of that time foundation will be executed or performed. So in that way, we can reduce some unnecessary function calls by the method of debouncing. Now we have the map and set. So if we are looking to store values in key value forms or even arrays or objects, then we can opt for maps and sets. So map and set comes out of the box with some dedicated inbuilt methods, which is specifically meant for retrieval and manipulation of data. So let's say if I want to store some object, so I can use new the map class, and in that I can store my values using set. So why we can use map? Because it is more performant in nature and doesn't come with some overhead methods or prototypes that we have for the object, so which are not meant to for the different retrieval or manipulation action that we are performing. And also same goes for the arrays. If we want to store some primitive values or even objects in form of arrays, then we can offer set. Now coming to some examples for code smells. Often when we are writing codes, there comes the scenarios where we are repeating the same logic across the application or across different files. So in that scenarios, we can have some common function which can be which can reduce this unnecessary copies of the same logic, and we can always reuse that piece of code across the application. Also, this will help us in any refactoring that needs to be done later in the code. So here I have taken example of calculating the volume. So first, let's say if we have calculation for area first, then which is width into height. So and the volume is again width into height into the length of the object that is there. So here you can see that the repeating part is the calculation of the area. So again, that can be turned into some reusable function so that it can be reused again when we are calculating the volume. So this is very small example, but when we are writing lengthy codes and we have some repeating piece of logic, that tends to affect our application performance and even hinders or leads to unnecessary bugs in our code when we are refactoring. So now there are times a situation where we write really lengthy function, or we have to write really lengthy some logical operation that needs to be done. So in that scenario, rather than writing a lengthy function which goes to 100 lines or 200 lines, so that can be reduced into small pieces, or small individual pieces, or separate functions. And that pieces of function can again be used in that complex function, so that again it is easy to understand for the other developer who is looking into the code. And if there is any refactoring, that could be easily achieved, because of that very long function that we have is split into the some logical pieces. Now similarly we have for large objects. So rather than having a single object, here is the example of a user object. So rather than having all the properties of the user in one single object, we can have them into separate small pieces. Like for personal info, we have two properties here. Then we have some properties for address. Similarly, we can have something for profession. Similarly, we could have some properties for hobbies. So all these things can exist into separate small objects, and those small objects can again be used in the primary object that we have for the user. Now coming on to nested callbacks, oftentimes we have uh, some uh, promises or some asynchronous actions or calls that needs to be performed, and that gets into a nested callback scenario, where the response of the uh, previous call that is occurring is dependent is needed for the next call that we are going to perform. So rather than going into nested callbacks, we can have a promise. We can write promises for them, and use them as sync await scenarios, so that it is very much understandable in the first glance. Like here we have example for we are fetching the data, then we are processing the data, and then we are responding with the uh, data that needs to be displayed. So rather than having it nested, we could have it in consecutive lines of code using the promises and async await. So these are some examples of code smells and some JavaScript improvements that we can do to improve the overall performance of the application. Now, moving on to RN component optimization, which Ashok will walk us through.
So, guys, in this segment, we will dive into the art of enhancing the rendering speed and overall performance of your application in React Native. So, in React Native, like any framework, any changes or can face any challenges in terms of rendering efficiency. But fear not, we will equip you with knowledge and technique to overcome these hurdles and ensure your application runs smoothly. So in React Native rendering, you can see that we can learn and optimize our code by using a variety of components using the that mentioned technologies. So techniques. Sorry. In rendering techniques and HOC, we will see in a demo as well. So we will have some style optimization, code optimizations, and state management. So in rendering techniques, at the core of optimization uh, is understanding and rendering techniques. React Native re-renders component when their state and props changes. So by implementing techniques should update, should component update or pure component, you can minimize unnecessary re-renders and improve the our app's performance by considering a list of components that updates whenever an item is added. By using pure component, you make sure that component will re-render only when new items are added in that list, not when or other unrelated changes will occur. And in a functional component, we should use React Native's built-in React.memo or use memo to minimize re-renders in functional components. So this ensures that the functional component re-renders only when its props are changed. And in higher order components are a more powerful way to enhance the component use and maintainability. Like they allow you to enhance and encapsulate the optimized functionality within your component and reducing your redundant unwanted code. So creating an higher order component for handling data fetching and catching, which can be reused across multiple components. So improving data management and rendering and efficiently. And by optimizing the style component, uh, we can uh, it can be impact on our app performance when overly complex or non-optimized style can load to the slow rendering. By minimizing unnecessary styles and adapting on a flexbox layout principle, you can ensure your application will run smoothly, your component will render and smoothly. Streamlining your style by using an external style sheet, keeping your styles consistent, and employing Flexbox for efficient layout management. And try to avoid an inline styling and always try to use an style sheet dot create to create any your style. And efficient code and significantly impact your app's performance, eliminating redundant operations, and be mindful of expensive functions. Technique like memorization, and it can be catch your result of your heavy calculations. This avoids recalculating values during every renders. And while we are going with state management, we should uh, check that proper state management is the key of reducing and re-renders, choosing the right state management approach like Redux, Mobax, and context APIs that allows component to update when only it's necessary. So implementing an Redux to manage and optimize component stateless, ensuring they only re-renders only when we have updated or changed in any data. Now we will see some good or bad practices while writing our code. So now, as we are seeing at the left hand side, we can see avoid use of scroll view to render huge list. There are a few ways that to display an items with scrollable list in React Native. Two common ways are implemented mostly, that are scroll view and flat list component. The scroll view is simple to implement. It is often used to over a list of infinite number of items as shown here, like you are using it array.map function. And on the other hand, using an scroll view with large amount of data can directly affect the overall performance of our React Native application. To handle a large amount of data in a list format, we should use the flat list. The items in a flat list are lazy loading. Hence, the app does not expensive or create any issue while loading an amount of data. Flat list can be used to show here that should be like here. Mhm. Now we will see some another example. Like in that example, we have that avoid passing an inline functions no props. So here we have one component where there we are just directly passing an function or any action on on press. That that's an bad way to handle this, because on time of its parent re-renders, a new reference of or the function creates an again and again. So this means that the child component re-renders even when the props doesn't change at all. The solution is to declare the function as a class method or a function inside functional component, so that the reference removes any possibilities of across retenders. So we should try like this while we are having an functions called create a function and then assign it to the props. Now we will go into the coding part. So we will see some examples here. So here we can see that we have some state for increasing an account, and we have some functions for increase count and decrease count, that are actions on the our main component. We are having that, and inner component we are having in a dashboard component. So we are loading here. So when we update anything on a main component, it will re-renders and our higher order component, which is dashboard, if we don't have handled it properly. So I will show you something like, if we have handled the dashboard component without an use memo, or is there any other way we can handle there? So I will show you that. So if we click on any of this button, it will re-render again. So we can see here it renders again, but it's not dependent because we are not changing the states from that component. Then also it re-renders. So we should avoid this by using an use menu. So here are the way. We just have to wrap our component inside an react.memo. So it will check that is having any props change or not. Accordingly, it will update your component and re-renders it. So by adding an this react.memo, let's see how it work now. So now we can see count is increasing, but that flat list is not rendering again and again, because it's that props is not changed for that flat list. Okay. So now we have another example, like we have a flat list, and on click of flat list we are updating the title, that we have the current title as the users list. So as we have one rendering component here, we are just passing it an title and handling it. So let's see here. Here we are just setting that title on on touch on press value. So whenever we are having this type of actions and we are just handling that title, like here, as we have here created one expensive function trying to do some for operations. So now it's an expensive function we can consider before setting any title. Okay. So when we try to do in that in this way, our function or our unnecessary redundance will happen. So let's show here. So when I update this uh, title on click of the list item, it will re-render the whole list, because we have not handled it in a proper way. So we should handle it like whenever needed, then only it should be get updated. So for that we have to use the our memorization callback function, that we should use uh, like this. So here we have one example. So we should do memorization callback and use the use callback hook to set that title. So we just have callback, use callback and the parameter here, and we are just setting it directly here. So if we just change this, then we can see the our response to that. I forgot one thing. We have to memorize this component as well. Here we can see on click of any of the item, title is changing, but it's not re-renders the whole list again. So here are two parts, like we can use the use callback and use memo, but there is a difference. Like when we use the use callback, it returns its function when dependency changes, and use memo will not returns a function. Like use memo calls the function and returns the result when dependency changes. So optimizing React Native component is the multiple phase task, but it's a crucial one for delivering responsive and enjoyable user experience. By applying these techniques, you will reduce the rendering overheads and improve your app's performance and take your React Native app to the next level.
Now we are having choosing the right dependencies. So oftentimes when we are building the React Native applications, we rely on the third-party libraries or dependencies to build the application in a much faster and efficient manner. But often that adds to the cost again. So there are some factors that we can consider when we are looking for the libraries or any dependencies that we are looking to add. So first of all, we should have a clear set of requirements so that we have an understanding whether we can build that same features on our own in the code itself, rather than relying on the dependency or the library. And if that requirement could not be achieved within the needed time frame, or in the project itself or in the application itself, then we will opt for looking into the options that we have for choosing the dependencies. And once we have the list of the options, or the list of comparable libraries that we need, then we should go through the documentation, whether it has the needed features or functions or the functionalities that is needed by our application. Then we have some license compatibility that needs to be looked on. So whether the licenses that are mentioned by the libraries meets the project requirements or not. So that also needs to be fulfilled. And then we have the number of downloads. So again, these number of downloads and the criterias, like how often that library is maintained, so all those things can be um, looked into looked into the npm page that we have for that library, or even the GitHub repository. We can have a look so that we get the idea of how the library is. So now, aside from these, there are a couple other factors that we have for choosing uh, React Native dependencies, or in fact, any of the dependencies for any of the project. So I mentioned checking the GitHub repository. So while we are checking the GitHub repository, we should always check for the open issues and what is the history of the GitHub repository, so that we understand how often the library is maintained, and if the open issues are being discussed or not, if that library itself is active or not, and if we are getting solutions to those issues or not. So that we should always check before committing to any library, because later on, when we move on ahead with the project and then we are finding out these issues, then it gets very difficult to change the libraries or switch libraries. Then I mentioned the version history. By version history here, I mean that to check how often we get updates for that particular libraries, so that we understand that some issues are being fixed and some new features are being introduced in the library. So that also we can look. Then we can look into the performance of the library. If what is the size of the library, so we can always have a look into that as well, because generally having very large libraries will add to the uh, performance of the performance of the application. Then we can always have some sort of POC, so that we understand the so that we understand whether the library meets our requirement or not, and whether the library itself is usable for the requirement or not. And we also have uh,
In the last part, we can see that the link is mentioned. There we can see our libraries. We can compare the libraries there, and we can check the usability, the percentage of how it's efficient with us for our requirements. So we can use that sync.io slash advisor website to verify our libraries before using it. Now we will move for some next section, that is code smells and bugs. This is the more like a performance killer. So these elements can act as a silent performance killer, lurking in your code and silently harming your app's efficiency. To build higher performance apps, it's essential to understand what code smells and bugs, how to identify them, and why a tool like CodeGrip you can use uh, to your best ally this journey, and it will help us to identify it easily. Bugs and code smells can be a real performance killer for your application. So make sure you have a best practices in your place to prevent them from impacting your application. So what are the code smells and bugs actually? So code smells are patterns in your code that might indicates deeper problem. They don't necessarily result in a bugs, but can make your code harder to maintain and extend it. The common code smells includes an duplicate code, long function, or any expensive commenting over there. And in case of bugs, on the other hand, are defects in your code that causes the unintended behavior or crashes in your application. They are more than just performance killer. They can understand and undermine your the functionality of your application. So tools to identify them is to maintain clean and huge code, to maintain and bug-free our code base. You need the right tools to use it and verify your code. By this tool using, you can detect it, and potential bugs and code smells can be resolved. So perform that, like we can say popular tools are like ESLint, Sonar, Qt, and CodeGit. So uh, the built-in debugging tool of your developing environment. So using an ESLint in your JavaScript-based application, a React Native project can help identify code smells and enforce coding standards and leading to the cleaner and more perform code base. And you are wondering about why code grips. So code grip is a powerful tool to analyzing a code that goes behind the basics. It's not just a tool to identify the code smells and bugs, but also provides insights into how to fix them efficiently. So, in our world of development, software development, we have to need an our powerful tools for our disposal, like code grip. So it's more than a tool. It's a guardian of code quality and working tightly to ensure that an code base maintains excellent. So with code grip, it's answered to in a era of automated code reviews. Every commit you make or every pull request you submit, this might go through the RGS evaluation. So this automation will help you to the code review process in the having an vigilant set of eye that inspects every line of code to spot issues before they become a problem. One of the key significant of the code grip is its ability to detect code duplication in a calculation of a duplication percentage and revolving area where our code base might be needlessly repetitive. Moreover, it doesn't just point out problems, it also offers and suggested solutions. It's like having an experienced mentor at your side. Another evaluation of the feature of code grip is its estimation of our resolution time. So it will help us to identify that how many bugs are there and how much time it will require to resolve them. And also, the good point is from the code grip side, code grip employs sophisticatedly have an algorithm to uncover the deep-rooted issues in your code that over tool might miss. Other tools like other we have they might be missed. So it doesn't stop the flagging the problems. It provides practical solutions and recommendations for fixing code issues. And also there is an ability that we can customize our rules according to our project specifications. And by utilizing code grip, you can evaluate your code quality, maintain the high performance apps, and deliver the seamless user experience.
Now, coming on to measuring app performance. So, for measuring app performance, we have a slew of tools that we have. So, we have Reactotron, we have Chrome developer tools, we have Sentry, we have Flipper. So, I'll just give you a comparison on how these tools compare to each other and how these tools can help us in improving our code. Starting with Reactotron. So Reactotron is a local debugging tool, and it helps us during the development process to inspect the state, the network requests that are going on. It also gives us analysis on the performance, and it gives us the timeline of the features that are going on in the application while we are running it. So Reactotron is primarily oriented towards the development process and testing. So it helps us in optimizing in those scenarios primarily. Also, it is open source, so it doesn't comes with any cost. Then we have Flipper. So Flipper is a tool again a similar set of tool which comes with monitoring the network, profiling the application, checking the network requests, the timeline of the view that we have. Then we have, this is again dedicated with it has dedicated plugin for React Native. Also, this is again this again helps us during the development and testing process. It gives us real-time insight into the application and the performance and the network activity of the application. This also is open source and doesn't come with any cost. Then we have Chrome developer tools. So this is the web-based tool that we have out of the box with React Native. So when we are using this tool, it has very limited set of features, though it allows some of the necessary ones, like we have sorry, like we have profiling for CPU usage, inspecting of memory, network analysis. So these are very limited features, but again, this can be the go-to option for the development process, because we uh, generally don't dive deep into the monitoring of the application. But when we have any special needs, like we want to optimize the performance of the application and need some deep insight into the issues which are hindering the performance of the application, then we can always opt for Flipper or Reactron. Then again, Chrome developer tool is free to use and doesn't come with any cost. Then we have Sentry. So Sentry is a enterprise tool. So it again, it comes with some cost, and this tool is meant for checking the performance of the application along in real world scenarios, along with all the necessary tools that can help the application improve or monitor the application for the real world scenarios, so that it can be checked for the production environment, and we can look into the issues early on whenever uh, we are planning on releasing the application. So this has some cost. So based on the requirement or the necessity for the application, we have different categories for the or different subscription plans for the requirement. So now we'll move on to key takeaways, which Ashok will let us know.
Yeah, so as we are up, wrap up our presentation in performance optimization in a React Native, let's recap the key takeaways. So we learn about the importance of optimizing and optimizing like React Native components and re-rendering of them, and improving the data manipulation and state management for code splitting and lazy loading. And we also learn about the JavaScript optimizations and making informed decision about dependencies. By implementing this technique, you can significantly enhance performance your React Native application. And now we will go for and build a blazing faster mobile experience. To further boost the importance of your application, of your React Native application that considers these practices, uh, minimizing the network request, optimize the image loading, catching techniques, use asynchronous operations wisely, and keep your code base clean and organized. By implementing these pointers, you can take your app's performance to the next level. So make sure you use the techniques like memorization and use component we should use the component update to reduce the unnecessary renders and enhance your UI responsiveness. And choosing the right state management approach will help us to handle data efficiently and reduce the rendering overheads as well. And streamlining your JavaScript code to minimize and execute time to boost your performance applications. And be sure while selecting your dependencies to prevent an abuse and keep your apps nimble. And always try to keep your code clean and maintain as well structured to organize code base for easier maintenance and better overall performance. And also we learn about the which are the measuring tools that we can use for measure your app performance, like Reactron, Flipper, Sentry, and Chrome debugger tool.
Thank you everyone for joining us. Reach out to us for any more questions. Thank you so much.